1324, presented by Professors Yvette Chuca, Ruben Carrizales, and Albert Isasi. This session will be recorded so that you may come back to it later if you need, and so others who may have missed out on today's events will be able to come and watch it. Thank you. Also, this event will provide Tejano Pass for points. The code will be posted on the chat at the end of the session for a Tejano Pass for points, and the link for the 1324 room will be posted in the chat if you're attending that session. So now at this time, please mute your mics for best sound experience. Otherwise, the feedback could interfere with information we'll be sharing today. Without any further information, here are our presenters for today.
Hello, everyone. Thank you for joining us today for Happy Math Hour. For 1314, we're going to review for exam one. For 1324, they're posting a link for you. So most of the 1314 classes are 10 weeks. So you're about getting ready to take exam one. So if you have any questions, please feel free to put them in the chat or open up your mic and ask your question. And so here we go. So the first thing that we want to cover, this is from section 1.1, find the distance and midpoint between the given 2 points. And so if you remember for the distance formula, the distance formula is d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Here in your given points, you can label these in whatever order you prefer. So for example, I went ahead and label my points here as x1, y1, x2, y2, but I could have easily called this one x2, y2, and x1, y1. So what you want to do next is substitute the values into the formula. So we're going to end up with 8 minus 8 squared plus negative 6 minus 4 squared. If we simplify, 8 minus 8 is 0. Negative 6 minus 4 is negative 10. And if we square the 0, it's going to be 0 plus 100. So this answer here, if you put this in your WebAssign assignment, it's going to count it wrong because it's not a simplified radical expression. So you want to simplify this. So you want to think about 100 and how you can break it down so that it has a perfect square in there. Well, actually 100 is perfect, right? So we would have the square root of 100 is 10. But if you don't have a perfect square, then you would want to go ahead and break it down. So for example, if you had the square root of, let me go ahead and get my pen, 54. Okay, so the square root of 54 is not simplified. So you want to find a perfect square. So when I see 54, I think about 9 times 6. And so notice here that 9 is a perfect square. Okay, so now the square root of 9 can come out as a 3. And then this 6 is not perfect, so it stays inside the square root. So this would be your simplified answer. Okay, now let's go on to the midpoint of this example. So the midpoint formula is x1 plus x2 divided by 2 and y2 plus y1 divided by 2. So if we substitute in the values, then we get 8 plus 8 divided by 2, negative 6 plus 4 divided by 2. 8 plus 8 is 16 divided by 2, and negative 2 divided by 2 simplifies, so we end up with 8 and negative 1. So then the next part of section, this will be then the next section, write the standard form of the equation of the circle with the given characteristics. So here they already give you the center, negative 4 and 2, and then they give you the radius. So the first thing you want to do is, since they're asking you to write in standard form, we want to make sure that we know what that standard form is. So I'm going to write it here, x minus h squared plus y minus k squared equals to r squared. Your center is we call the first coordinate h, and then the second one is k. And then my radius, I'm going to say r equals 2. Substitute the values. So we get x minus h, which is negative 4, and then y minus k, which is 2. R is 2, and then we're going to simplify. So negative negative is positive 4, and then y minus 2 is already simplified in the parentheses, and 2 squared is 4. So the standard form of your equation, this would be the answer that you want to input. Now here they give you the equation, and they want you to identify the center. So the first thing that I would do is I would write the standard form, and then we have x minus h squared plus y minus k squared equals to r squared. Again, remember that if we write this right below it, then if we compare it to the standard form, we have x is x, we have our subtraction sign. That means that h is going to be 1. And this side we have y is y, but now our subtraction sign is not the addition sign here. So we can rewrite it. And notice if I rewrite it, then we have, and I'm going to go down to this slide here. So now I can have this addition sign rewritten as subtraction and a negative sign, because together, if you multiply, we get positive. So now we have a subtraction. So that means that k is going to be negative 2. And then for r squared, we have r squared is equal to 25. Our goal is to solve for r. So we set up an equation, r squared is equal to 25. Take the square root of 25, so we get 5. So our center is going to be 1 and negative 2. Now the shortcut for this is basically, here we have x minus 1, so you take the opposite of minus 1. That's going to be a positive 1. Positive 2, the opposite of that is negative 2. The steps that I wrote here is just to show you why we can use that shortcut there. Now that we have our center and we have our radius, we can actually graph it. We can sketch the graph. So my center is at 1, negative 2. And so from that center, you want to use the radius to go up 5, down 5, to the left 5, and to the right 5. Okay, so let's go ahead and do that. So I've plotted the points here. So we went up 5, to the left 5, to the right 5, and then down 5. And then we just sketch the graph. So that would be our sketch. Yep. So the next part we have is find the intercepts and test for symmetry. So first we'll find the intercepts. So whenever you find the x-intercept, we let y equal 0 and solve for x. And so we're going to subtract 1 on both sides. And then we're going to divide by negative 4. So my answer is going to be 1/4 and 0. Then we have our y-intercept. So we're going to let x equal 0 and solve for y. So we get y equals negative 4 times 0 plus 1. So our y-intercept is y equals 1. And if we look at this graph, you can see that it has no symmetry. But sometimes you might not be given the graph. So we can find out if it has symmetry algebraically. So to do this, these are the 3 tests. And so we have the x-axis symmetry. For the x-axis symmetry test, what you want to do is change the y value to a negative y and evaluate the equation to see if you get the original equation. So here I have my original equation. I'm going to replace the y with a negative y, and then I'm going to solve for y again. So I'm going to go ahead and divide by negative 1 so that I can get a positive y. And then I divided everything by negative 1. So I'm left with 4x minus 1. So you want to compare this equation with your original equation. If they're the same, then that means that there's x-axis symmetry. Notice that they are not the same, therefore there's no x-axis symmetry. For the y-axis, we do similar tests, but instead of changing the y's, we're going to change the x. So the x becomes a negative x. And let's go ahead and do that. So here's my original equation. I'm going to replace x with a negative x, and then I'm going to simplify. So negative negative is positive 4x. If we compare this equation with the original, it's not the same. Therefore, there's no y-axis symmetry. Now for the origin, we have to change both the x and the y. So here's the original equation. So I'm going to replace y with negative y and x with negative x. And then I'm going to go ahead and solve for y. So negative negative is positive. And then I'm going to divide by negative 1 on both sides. And so I get y is equal to negative 4x minus 1. If I compare, they're different. That means that there's no symmetry on the origin, which we could see from the graph, if I go back, that there was no symmetry. Okay, so that is how we would do it algebraically if we don't have the graph. Oops. Okay, so the next part is determine whether this is a function. So by now, you have covered several sections in chapter 1. And so in 1.6, you looked at different types of graphs. So hopefully when you see this first equation, you should hopefully remember that this is going to be a line if you graph it. And so if you know what the graphs look like, then you can figure out if it's going to be a function by using the vertical line test. So this first one, we know it's a line, so it's going to look something like this, right? So any line is going to pass the vertical line test. So that's going to make this a function. If we look at the second equation, since we have the highest power is a 2, that means that this is quadratic. So that means that the graph is going to be a parabola. And so if we draw the parabola, then the parabola will pass the vertical line test. So it's also going to be a function. The third one is part of the square root family. So if you remember in 1.6, the graph for the square root family looks like a little arrow pointing to the right. And so this picture is also going to pass the vertical line test. So we would say, yes, it's a function. And then the last one, since both the x and the y are squared, then anytime that you have the x and y variable squared, that means that your graph is going to be a circle. And so if we draw a vertical line, it's going to touch the graph in 2 places, and therefore it's not going to be a function. Okay, here I have a couple more. So this one, the highest power is a 3, so it belongs to the cubic family, and the graph is going to look something like this. And so this will also pass the vertical line test. Now in this next example, this is a little different because it's not part of the parent functions, right, that we have seen. And so for this example, what you can do is solve for y. So if I solve for y, I get plus or minus the square root of x plus 4. So basically I'm getting 2 solutions, right? I'm getting a positive solution and a negative solution. Now if we look deeper, if I select the number for x, let's say 0, when I plug it in the first equation, I get the square root of 4 is equal to 2. And I plug it in the second one, I get the square root of 4 is equal to 2, but I have a negative in front. So for when x is equal to 0, we get 2 answers. We get 2 and we get negative 2. Therefore, this is not going to be a function. Now the graph for this looks like a parabola that is on the side. So if you draw a vertical line test, it's going to fail the vertical line test, making it not a function. Okay, so hopefully by knowing what the graphs look like, it kind of helps out a little bit. The next part, which is I believe 1.3, use the graph to write the equation of the function. So here, the first thing you want to do is recognize which family of functions it belongs to. So this is going to belong to the square root family. And then I always like to make sure that I know what the square root of x looks like so that I can compare it to my graph that they give me. So in order to take the original parent function so that it looks like this graph, what is it that had to happen? Well, we had to move to the left and then we had to go down. And so now we can plug that information. So to move to the left, remember we do the opposite. So we're going to do x plus 2. And then to move down, we're going to subtract minus 8. So it's going to go all the way down to minus 8. Okay. So that would be our solution, our equation. Now let's look at this one. This one's still from the square root family, but if you compare it to our previous one, the arrow's pointing to the right. But now the arrow is pointing to the left. So we need to figure out why that happened, right? And so when you were looking at these graphs, you learned about reflection on the x-axis and you learned about reflection on the y-axis. So let's break this a little bit down. So we have square root of x, that's your parent function. And now somehow there was movement to the right. So I'm going to move to the right 2 units. So some of you are going to be tempted to do it this way, and that's fine. You just have to be careful at the end, okay? So here we're going to shift to the right 2 units. That means that I'm going to write the opposite sign, which is negative. Okay, so now I move to the right. And now I need it to go down. So if we look at the original graph, it got shifted 5 units down. So to do that, we represent it with a minus 5. So now my graph that was here is going to be shifted down 5 units. The only problem now is that we have it in the right location, but it's not pointing the right way, right? So there's reflection taking place. So the 2 types of reflection is one on the x-axis. If you want it to reflect on the x-axis, then you need a negative on the outside of the parentheses, of the square root. If you want it to reflect on the y-axis, you're going to need a negative inside of the square root. So let's see let's apply both. Okay. If I apply the negative on the outside, then it's going to reflect, so it's going to turn upside down. And so you can see it here from the purple arrow. But does this graph look like the one that we're hoping to have? It's not quite there yet. So now that means that there's reflection on the y-axis. So we're going to go ahead and add the negative inside. And so by adding that negative, now my graph is reflecting, and it's this black one that I'm tracing with my mouse. And so now this graph, if we compare it, it does look like our answer here. But notice here that I have a negative and then I put parentheses, okay? The reason is because I need to apply the negative to everything that is inside the square root. And so my final answer is negative x is going to be negative x, and then negative is positive 2. So one of the questions that I have gotten from my classes is, why is it a plus 2 if the graph is shifting to the right? Shouldn't it be a negative? Because that's the opposite. So remember, we started with the negative, but because we applied the reflection, that negative is going to change your minus 2 to a plus 2. Okay. All right, so let's continue. The next part here is write equations of the lines through the given point that's parallel to and perpendicular. So they give you an equation. So what you want from this equation is the slope. So let's go ahead and find the slope. So I'm going to subtract 8. So I get negative 8x plus 3. And then I'm going to divide by negative 2. Okay. So 8 divided by -2 is 4, and 3 divided by -2 is negative 3/2. So from this equation, the only thing that we are interested in is the slope. So I'm going to write it here. So m is equal to 4. For parallel lines, we use the same slope. So we're going to use m is equal to 4. And then we have our point, which is 8 and 1. And then we're going to use the point slope formula. So we have y minus y1 is equal to m times x minus x1. Substitute our values. So we get y minus 1 is equal to 4 times x minus 8. Distribute the 4. So we end up with 4x minus 32. Add the 1. And so our answer would be y equals 4x minus 31. So again, for parallel lines, you use the same slope. For perpendicular line, we're going to use the negative reciprocal, which means that if this is positive, you're going to change it to negative, and then you're going to flip the fraction. So this is 4 over 1, and we flip it, we get 1/4. If this was negative, then you would use a positive. Then we substitute the values. Let me get some water. Okay, so now that we have our slope, we're looking at perpendicular lines. We're going to distribute the negative 1/4 in for x and into the 8. So we get negative 1/4 x minus negative 1/4 times negative 8. Simplify. So negative 8 times negative 1/4 is positive 2. And then we're going to add the 1. So if we add the 1, we get a 3. And we end up with y equals negative 1/4 x plus 3. Okay, another problem that we have here, consider the following. F of 1 is equal to 7, f of 0 is equal to 8. It says write the linear function. So these are your keywords. Write the linear function. That means that you need to have a slope and you need to have at least one point. And then you can use the point slope formula or the y-intercept of a line. So if we look at these points a little bit closer, inside of the parentheses, that's your x coordinate. And then the result is your y coordinate. So here we're going to have our points 1, 7. And the second point, our x is 0 and our y is 8. Okay. So we need a slope, so we can use the slope formula. So we're going to have 8 minus 7 and 0 minus 1. So we get 1 divided by negative 1 is equal to negative 1. Now from these 2 points, one of them is special, right? This one 0, 8, because that's going to be your y-intercept since x is 0. So we don't have to do extra work. But if you didn't have this point, then that's when you would use the point slope formula, which is y minus y1 equals m x minus x1, and then you would use one of these points. Okay. But since they already give you the slope intercept form, then we don't have to do that extra step. So now we just substitute those values. So I actually did the work here, but the slope is negative 1, and then the b is going to be 8. So negative 1x is the same as negative x. So that's your equation. Okay, the next thing that we saw in one of the sections, probably 1.5, is to evaluate the function. So if we have f of 1, we're going to take that 1 and we're going to plug it in for wherever we see an x. And so if we do that, we get f of 1 is equal to 3 times 1 minus 8. And so 3 times 1 is 3, minus 8 gives us a negative 5. Okay. The next one, you're going to take everything in the parentheses. And again, we're going to substitute it in for the x's. So what we get is f of x plus 4 is equal to 3 times x plus 4. Simplify. So we're going to take 3 times x is 3x. 3 times 4 is 12 minus 8. 12 minus 8 is 4. Let's do g of 2 here. So same thing, we plug in the 2. So we get 5 times 2 squared minus 6 times 2 plus 4. And here it says substitute for x, but it should be substitute for t since our variable is t. 2 squared is 4. 5 times 4, and then we're going to have 6 times 2 is 12. 5 times 4 is 20 minus 12 plus 4. So we end up with 12. And let's do one more. So here we do the same, plug in the t minus 2 for every t that we see. And if we simplify here, we get t minus 2 squared is the same as t minus 2 times t minus 2. And then I'm going to multiply negative 6 times t. Negative 6 times negative 2 is 12. And then we have plus 4. So in this parentheses, I'm going to multiply t times t. So we get t squared, and then t times negative 2 is negative 2t. Negative 2 times t is negative 2t. And negative 2 times negative 2 is positive 4. And 5, let's combine like terms. Negative 2 is negative 4t. Distribute the 5. So 5 times t squared is 5t squared. 5 times negative 4 is negative 20t. 5 times 4 is 20. So we have a bunch of stuff here. Let's combine like terms. Negative 20t and negative 6t is negative 26t. 20 plus 12 plus 4 is 36. And that would be our answer. Here I have 2's that are separated, right? We're subtracting. So g of t, we figured out earlier, is 5t squared minus 6t plus 4. And g of 2, we plug that in, we get 12. So since we already have our t and we have our 2, now we're going to subtract it. So we have g of t, which is 5t squared minus 6t plus 4, and then g of 2 is 12. Combine your like terms. 4 minus 12 is negative 8, so that would be our answer here. So here now we're adding and subtracting. Okay, so the first one, f plus g of x, remember you can rewrite it as f of x plus g of x. F of x is x plus 2, that's given to us up here, and g of x is x minus 2. So if we combine our like terms, x plus x is 2x. 2 plus negative 2 is 0, so my answer is 2x. If we subtract, again, we can rewrite it as f of x minus g of x. So we end up with x plus 2 minus. Don't forget parentheses because the minus will be applied to everything. So negative x and negative negative is positive 2. So x plus a negative x is 0. 2 plus 2 is 4. And then the next one, x plus 2 times x minus 2. We get x squared minus 2x plus 2x minus 4. The 2x and the negative 2x should cancel. Okay, so our answer should be x squared minus 4. So let me just, so this shouldn't be here. So that should be our answer. Okay, and then f divided by g, we have f of x divided by g, and we can simplify further, so that would be our answer. Now the domain of f divided by g, notice that you have a fraction. Since you have a fraction, that tells you that there's some numbers that cannot be used as part of your domain. And those numbers are the ones that will cause you to have a 0 in the denominator. So if I have a 2 here, 2 minus 2 would give me a 0. That means I cannot use 2. But if we are not able to see that number there, then what you want to do is take the denominator and set it equal to 0 and solve for x. So here we get x is equal to 2. So the domain is all real numbers except for 2. So the way we write that is we write from negative infinity all the way to 2. I'm going to use a parentheses because the parentheses tells me that I cannot use that number. And then union 2 to infinity. Okay. Evaluate the function we're multiplying. So here we have f of x times g of x. So we get x plus 3 times x squared minus 2. So we're going to multiply the two parentheses. X times x squared is x cubed. X times negative 2 is negative 2x. 3 times x squared is 3x squared. And 3 times negative 2 is negative 6. So we end up with x cubed plus 3x squared minus 2x minus 6. Compositions. If you see this symbol, that means composition. So basically, you want to rewrite it as it's defined. So this symbol, we can write it as f of g of x. And then we're going to substitute what we have. So here we have f of g of x. Well, g of x is x minus 9. So I'm going to replace it here. So now I have f of x minus 9. So we're going to evaluate f of x. Okay, so that should say f of x. So we're going to take x minus 9 and we're going to plug it in for the x in the function f. So now we're going to go ahead and do that. So here I have an x. I'm going to replace it with x minus 9. And then I have the plus 4. So we end up with x minus 5. G composed of f, we write it as g of f of x. So f of x is x plus 4. And if I plug in, I'm going to take this information and plug it in for g. So x plus 4, I'm going to plug it in right here for x, which is x plus 4. Then I have the minus 9. Then I have the minus 9. So I end up with x minus 5. And then we have g composed of g. So we get g composed of g of x. G of x is x minus 9. And now we're going to take all of this and plug it in back for g. So here's my x. I'm going to plug in x minus 9. And then we have the extra minus 9. So we get x minus 18. Let's see. Let me go back. Okay, so this is a different one. So we have f composed of g. So here we have g of x is x minus 1. We're going to take this information, plug it in for x for the f function. So we end up with x minus 1 squared. So x minus 1 times x minus 1 gives me x times x is x squared. X minus 1 is negative x. Negative 1 times x is negative x plus 1. Negative x is negative 2x. So my final answer here is x squared minus 2x plus 1. So here we have g composed of f of x. F of x again is x squared, so we plug it in. And now g of x squared, that means we're going to take this information that is for function g, and we're going to substitute it in for the function g. So we're going to take this and plug it in for x right here. So if I do that, then I have x squared minus 1. Simplify, we end up with x squared minus 1. Then the last one, g composed with g. We take x minus 1, plug it back in for x. So we get x minus 1 minus 1, which is x minus 2. The next part is inverses. So here, if you have an inverse, it has to be a function. So this does pass a vertical line test. To see if it has an inverse, we're going to use a horizontal line test. Okay. So what this is saying is if you draw a horizontal line and it touches a graph in one location, then that means that it's going to have an inverse. And it doesn't matter where you draw the red line or the line, it's going to touch it in one place. Therefore, it's going to have an inverse. Okay, so it says determine whether the function has an inverse. Well, one, this function is a function, right? This is a line. So then we're going to go ahead and find the inverse. So this is a line. It's going to have an inverse. So to find the inverse, this is what we have to do. We take our f of x, we're going to replace it with y, and then we're going to interchange the variables. So if you have a y, you're going to make it an x. If you have an x, you're going to make it a y. So now this equation is going to be x is equal to 5y plus 4, and then we're going to solve for y. So we subtract 4, and then we divide by 5. So my inverse, our last step is change that y to f inverse, and we end up with 1/5 x minus 4/5. Okay, so these were just a few examples of um, problems from the entire chapter 1 section. And so, as I mentioned, this for those of you that are taking a 10-week 13-14 class, then this week you're more than likely going to be taking your tests. And if you are in a summer 1 session, then maybe this is a review for you for your final already, right? So if you have any questions, we do have tutors here that can help you. If you want to download this presentation or this PowerPoint, right here where my mouse is, you should see a box with an arrow pointing down. If you click on that, it'll let you download the PowerPoint. So next week, we're going to start going over chapter 2 problems. And so hopefully we can see you here again. Make sure that you signed in and everything, and I will pass it back over to our staff.
Thank you, Ms. Shuka, for this amazing presentation. The next week, we will have the quadratic and synthetic division for Math 13-14 and exam for review for Math 13-24. Thank you so much to the audience for coming and being a wonderful audience. See you the next week. Also in the chat, we have the survey. Please, you can click in it and answer 3 questions. Thank you to everyone. See you the next week. Bye-bye.